right, so we're talking about something. I know that you don't want to learn, but I promise that we're doing this because of next year. If you're not going to be in calculus class, you just have to endure today. But if you are going to be in calculus class, it's going to make your life easier. So we're talking about something called continuity today. Sounds scary? It's not scary. So that's not what I want. I lost my papers. I hate it when that happens. Where did they go? I have graphs for you, but I don't know where they went. Well, guess we're not making graphs for you. I'll see if I can find them in a minute. Okay, so continuity. Continuity is a characteristic of graph. And actually, let me pause a second. What's the root word in the word continuity? Continue. So we're talking about if a graph is continuous or not. And so we need to talk about what does it mean if a graph is continuous. So that's the property is called continuity. Oh, fudge. I gave one to Macy. I don't know where they went. I hate it when that happens. Okay, I'll just draw. It's fine. So continuity is a characteristic of graphs. The root word is continuous. Continuous. So a graph is continuous. I'm going to give you the non-mathy definition. So a graph is continuous if you can draw it without lifting your pencil. Okay, so if you draw a graph and you just pick up your pencil and you're like, hey, whatever, you make your graph. That is a continuous graph because I can draw it without lifting my pencil. Okay, there are 3 ways that graphs cannot be continuous. So we honestly don't talk about continuity as much as we talk about what makes something not continuous. So there are 3 types of discontinuity. Okay, so discontinuity is the opposite of continuity, right? It just means that it's not continuous. So the first one is a hole. We've talked about holes a lot. Okay, we know that if we're doing the equation, we have 0 over 0. If we're finding a limit from an equation and we have 0 over 0, then we know that there's a hole there. Okay, that's called a discontinuity in a graph because I cannot draw a hole. I feel like if Jack was here, he would argue with this. But I cannot appropriately draw a hole in a graph without lifting my pencil. Okay, so like if I was gonna draw this, I'd have to pick up my pen, draw the hole, and keep going. Now, there are people in the world that would be like, hey, I feel like Jack would be this person. So I'm going to draw this. I'm just going to go around the roundabout and go out the other side. And I didn't lift my pencil, so it's not a discontinuity. You guys, I'm so right about Jack arguing about that. Are you trying to draw your graphs in cursive? No. So anyway, you get the idea. If there's a hole in this graph, it's not continuous because by definition, it doesn't continue. There's a hole in it. There are 2 kinds of holes. So there's this guy where it's just the hole, or you can have the extra point on there. So it may or may not have its extra point. That's still considered a hole. Even though there's a defined point, they're both holes in your graph. Okay, that's the first kind. The next thing is called a jump. Okay, this one, there's no arguing. Like you can't draw this. Right? If that's where your graph stops and it picks up at a different y value. Okay, that is a jump. These endpoints here, they could be both open, one closed. You can't have them both closed because then it's not a function. right? Because it doesn't pass the vertical line test. And then the last one is vertical asymptote, which we've also talked about. Okay, and so we know vertical asymptote. You can have them going both up. You can have them going both down. You can have one up, one down. Okay, so vertical asymptote. So there's three kinds of discontinuity. So one of the things you're doing on your homework literally is classifying the kind of discontinuity. I'll give you a graph. You're telling me, oh, that's a hole there. Okay, it's literally that easy. Now, I'm going to give you, this is my Mrs. Douglas definition of continuous. You can draw the graph without lifting your pencil. There is a mathematical definition of continuity. Okay, so it's very mathy, and I want you to write it down because I want you, first of all, to understand that you are smart enough. I believe in you. You're smart enough to interpret a math definition, but I'm going to also teach you how to do that. So continuity, I'll move my knuckle in a second. So write it down. Like I said, I'm going to show you how to interpret that. Okay? Because they look terrible, but they're not as bad as they look. Some of them are. I'm not going to lie. Some of them are as bad as they look, but not as bad. So there's something in math called, this is continuity at a point. We're talking about a specific point. There's continuity on an interval. That just means if everything on a certain bunch of x values is continuous, it's not scary. Or a graph could be continuous for its whole domain. It means there's no discontinuities at all. Anyway, so let me tell you, when you have a math definition, it starts out, the first bits of this, so like this first, you don't have to draw all over yours, but this first bit here, all that's doing is letting you know, number one, what are we talking about? We're talking about continuous. And number two, I'm just telling you what it is we're talking about. So I'm naming f of x so that you don't go, what the heck is f of x and where did it come from? We're talking about a function or a graph. Okay? And then the other one just tells you where it says x equals c. That just names the fact that we're talking about a y value. Okay? Or, I'm sorry, we're talking about an x value, not a y value. We're talking about an x value and we're going to call it c. That's all. Because we can't call it x because we already have x's all up in here. Okay? So, the first part of that, which is the words people freak out at sometimes, just is defining what we've got going on. The second thing, though, you know what this means. We've been dealing with this. What is that? Just this part of it. Not a rocket science question here. Oh, it's just a limit, right? This is just a limit. So this is saying this is going to be continuous at x equals c. So if the limit exists. So what does that mean? It means that you have to have a limit. Okay, that would be my interpretation. It has a limit. Okay, so this is a c. That's a c, not an l. This says f of c exists. If this is the limit, f of c is what? Close. F of c is the x value. So f of c would be its y value. Okay, so it just says the y value exists. Okay, so now that I say this, I hope you go, oh yeah, I see that. The limit as x approaches c of f of x exists. That means it has a limit. This means it has a y value. Now, what does the last piece tell you? And they're equal, right? They're equal. Okay, so something is going to be continuous if it has those three properties. Okay, so let me show you. Because I lost my papers. So I guess I'm gonna draw. We'll try not to make them super complicated here. Okay. So let's talk about the x value of 3. So if I was going to talk about continuity, first of all, would you say that this is continuous here? Yeah, does not have a hole, it does not have a jump, it does not have an asymptote, okay? It's continuous. So I want to explain to you what this means, okay? So using your graph, which we took a quiz on yesterday, what's the limit as x approaches 3? 2, because from the left and from the right, we're right at y equals 2. Okay, what's f of 3? 2, because if I go to 3, the graph's at 2, and notice that those are the same. Therefore, this is continuous. That's what the definition means. It has a limit, it has a y value, and the two things are the same. Now, I told you a minute ago, we don't tend to talk a lot about continuity because that's normal. We talk about those discontinuities. Okay, so let's talk about, I hope you can still see your definition there. Let's talk about holes. Okay, we're going to talk about both types of them. Okay, so we'll say I got this hole here. We'll say this is a y value of 2, an x value of 2. And we'll say this is a y value of 4. For example, okay, this guy, does he have a limit? What's the limit? 4. Okay, now, does he have a y value? So what's f of 2? Doesn't exist. That's undefined. We say undefined when we're talking about functions because, I don't even need that arrow. Because this does not exist, it violates number 2. Like that definition of continuity that I gave you, number 2 does not work, right? F of c does not exist. Therefore, this is not continuous, okay? Because there's no y value there. So if I was going to say this, I would say to you, hey, is this continuous at 2? And you would say, no. And I would say, why? And you would say, because the y value does not exist. Okay? Or you could say, if you don't want to write that much, you could say f of 2 does not exist. That's less writing if you wanted to say that. Okay? So in a hole, it is discontinuous because there's no y value. You could also say no y value if you wanted to. Now, let's look at this one. Okay, so let's go 2, and let's make that 1, and let's make this 3. Okay, so this is the other kind of hole. This could be a hole with a floater, or it could be a hole with a sinker down here. Okay, it could be either kind of hole. I just drew it up there, it doesn't matter. Okay, so I'll just ask you now that I've given you this example. Does this have a limit? What's its limit? 1. So it has a limit. So the limit as x approaches 2 of f of x is equal to 1. Okay. Does it have a y value? What's its y value? 3. There's a 3. Okay. It's 3. But look at, those don't match. So the problem that it doesn't have is that the reason it's discontinuous is because the limit and the y value aren't equal. So if I was going to say y, like you would say, this is discontinuous. And I would say why, because you would say the limit does not equal the y value. Okay. The limit doesn't equal the y value. On the other page, I'm going to go back. Here, the limit was 2 and the y value was 2. So this is continuous. Over here, we've got this floater point, or it could, like I said, it could be a sinky. And the limit is 1, but the y value is not in line with everybody else. So it's not continuous. Let's talk about a jump. So we'll make them double open there. Doesn't really matter what the x value is. This is not continuous. Okay, I already told you it's a jump. It's not continuous. But why? Looking at those 3 pieces, why is this not continuous? That doesn't have a limit. Correct. Right? Because his limit from the left and his limit from the right are different. So because he does not have a limit, he's not continuous. Okay, last one, vertical asymptote. I'll draw this guy over here. Whoop. Like that. Also not continuous. Why not? Yeah, but why? Look at the definition of continuity. Which of the 3 things causes a problem? There's no y value. That would be one thing you could say. This guy also does not have a limit, right? Because he's not getting anywhere. This just continues to go down and down and down. This continues to go up and up and up. In order to be a limit, it has to actually get somewhere. So on this one, I would take both the answers. You could say that there's no limit or there's no y value. Okay, look at, I just want to ask you this question, and then I'll be done. Okay. Let's say this with the asymptote and they both go up. Okay, and I want you to listen carefully to the question. Let's say this is 3. Okay, x value. What's the limit as x approaches 3? Positive infinity, right? That's you guys talked about that the day I was gone. Now, this is where your mind might explode a little bit. Does that limit exist? It does not. Okay, because this doesn't get anywhere, right? Infinity is not a number. It has to get to a number if it's going to have a limit. So sometimes in the past, people have said, well, I put an answer, so it has a limit. If it's infinity, it's not a limit. We're just describing how it acts. So this guy also does not have a limit. So this guy was no limit. This guy is no limit. Okay, so when you have your homework, what you're going to have, and you'll have plenty of time to finish it in class, you're going to get a graph. So I might be like this, and it's going to say, what kind of discontinuity is that? What is it? It's a hole. And then it's going to say why, based on that those 3 pieces of the definition, why is it discontinuous? And you would say, what? Yeah, there's no y value. Okay, so that's what you're doing for your homework. You're just saying, what kind of discontinuity is it? And why, based on the definition, is it not continuous? Okay, that is the last lesson for the school year.